Hello everyone. In this presentation, we're going to talk about adding intellectual property IPs to your designs that you create in Intel-Altera Quartus II tool. When we work with FPGA boards like the one that we use in now in this course, the one SoC, it has a certain FPGA device like the Cyclone 5 that we're looking at. Most of the FPGAs today include several different things, intellectual property or IPs embedded inside the FPGA fabric, including quite often PLLs, phase locked loops, that are really handy, useful for implementing clock generators because they are very stable, very accurate, and therefore very useful in a lot of applications that require accurate, stable clock signals, which for all practical purposes, pretty much most of the real designs out there need that. So it's a really, really helpful, useful IP that we'll look at how to integrate in our designs. Before looking at how exactly to add to our projects an IP like the PLL IP, one should really go and search and dig into the documentation about that IP. And Intel-Altera documentation is a lot, can be quite messy. There are lots of old and new documents, including data sheets, device overviews, handbooks, and many others. Perhaps at some point too much of it. The main point is that one should read and understand what that IP is all about and how maybe it works and how it could be configured before going ahead and using those. So I will demonstrate how to create an PLL IP into a Quartus II project by looking at a specific example, the digital clock, which is a really simple design in a way in that it implements a clock that counts seconds, minutes, and hours and displays them on the 7-segment LEDs that we have on the D1 SoC board. For counting time in increments of 2 megahertz that would be used to count seconds, minutes, and hours, we use a PLL as a clock divider that takes as an input the accurate, stable clock signal of 50 megahertz from the crystal quartz oscillator that we have on the board and divides it to 2 megahertz precisely. So this is the IP, the PLL that I will show you how to use. Here is the Quartus project. This implements that digital clock. This is the top level design entity declaration with all the input and output ports as shown over here and as shown on that block diagram earlier. I had this project already created at some point, and the PLL IP had been already included here as a component, so I'm going to delete that so that I'll show you all the steps. So adding the PLL as an IP to our design is really easy. All I have to do is to go here on the right hand side under the IP catalog library, expand that, expand clocks, PLL and resets, PLLs, and then select the PLL Intel FPGA IP. Once this is selected, this add that button becomes clickable. Press that, and then this little dialog window is asking us to specify the file type. We'll go for VHDL because we're working in VHDL. Give it a name, my underscore PLL. You can give it any name you want. Say OK. Well, this overrides previously created IP, so I'll just overwrite everything to do it from scratch here. and this Mega Wizard tool that comes with Quartus shows up. Um, and it's a very neat tool that allows us to configure this PLL. In our case, I have to type here input a 50 megahertz reference clock, because that's what we get from the crystal oscillator on our board. And while I would have liked to have an output frequency of 1 megahertz, that's not doable. And I'm just gonna go with just 2 megahertz, which seems to be something that I can get out of this PLL. I don't need the locked output ports. I will unselect or deselect here. You'll see that is reflected in this symbol block diagram that shows the inputs reference clock, reset, and output clock 0. Everything else I will leave at their default values. Click finish. The tool will generate the files that will be added to this project. It's going to take a few seconds. Generation successful, exit, and then you'll see how those files are related to this IP are added to the project. If you expand that and open the MyPLL, you'll see it here. So to be able to instantiate that as a component and the top level design entity, I would take it from here. I'll copy it from here, bring it in here, and include it, paste it as a component. Of course, so this is component PLL and component. That's pretty much it. I have it here declared as a component. Of course, I would need to instantiate it, port map it in the top level design entity as indicated on the block diagram, and I think I already have it here. So that my PLL needs to be port mapped, and like so. The reference clock, the input is connected to the input port clock 50 megahertz external that comes into this top level design entity, brings the signal from the quartz oscillator, reset is hard coded to 0, and the output goes to clock underscore 2 megahertz that will be used as an input clock to several other components in the top level design entity. That's pretty much it. Let me compile, place and route, and program the FPGA, and I'll show you how this works. Well, I have programmed the FPGA board. Let's look and see how that works. So this is the digital clock, the reset, the slide switch, seconds, minutes, hours. I can set the hour to whatever time I want, the minutes as well. I can even set the seconds and let it go. So this is just a simple digital clock, nothing really fancy, but it is based off a clock signal that is generated using that PLL IP that takes as an input a very stable 50 megahertz crystal quartz oscillator generated clock signal that is very accurate. In conclusion, the main takeaways are adding IPs to our design entity in Quartus II is really easy. Just add the IP that you need and configure it using the Mega Wizard. Perhaps searching and reading for the documentation of these IPs that we use first to be able to know and understand how exactly we configure the IPs is an important aspect that needs to be emphasized. That's pretty much it. I'll see you next time.